determine whether a triangle is a right triangle. Think about this question during the lesson. Triangle ABC has side lengths A, B, and C, so that A squared plus B squared equals C squared. Construct a logical argument to show that triangle ABC is a right triangle. You have to show that angle B is a right angle to prove that triangle ABC is a right triangle. Let's draw right triangle DEF with leg lengths A and B and hypotenuse length X. Since triangle DEF is a right triangle, by the Pythagorean theorem, we know A squared plus B squared equals X squared. We can use substitution to show that C equals X. We are given that A squared plus B squared equals C squared. And we know that A squared plus B squared equals X squared. By substitution, C squared must equal X squared. If we take the square roots of both sides, then it also must be true that C equals X. Is triangle DEF congruent to triangle ABC?
Select your answer.
The three sides of triangle DEF are congruent to the three sides of triangle ABC. So there is a sequence of transformations that maps triangle DEF to triangle ABC. The triangles are congruent. Therefore, angle E must be congruent to angle B. Angle B is a right angle, so triangle ABC is a right triangle. This is a proof of the converse of the Pythagorean theorem. If A squared plus B squared equals C squared, then triangle ABC is a right triangle.
A triangle has side lengths 4 inches, 5 inches, and 7 inches. Is the triangle a right triangle?
So we need to put the numbers into the equation to see. So if we take the numbers and put them in, we have 4, 5, and 7. 4 squared is 16, 5 squared is 25, 7 squared is 49. So this would be 49. And then, excuse me, 16 plus 25 is not 49. So because they are not equal, is it equal? You say nope. And is the triangle a right triangle? You say no, because if it's not equal, excuse me, then it is not going to be a right triangle.
Part A. Is triangle XYZ a right triangle?
So we look here, we have X and Y, Z, 7, 24, 25. So drag the tile, substitute the equation. So the 7 is found here. That's one of our legs. So that's going to be A. And then the other leg is 24. And then our hypotenuse would be the 25. Now, once we do that, we solve it. We have 49. 576 equals 625. You add those together, it does equal 625. So triangle XYZ is a right triangle.
Part B. The side lengths of a triangle are 6 inches, 4 5/10 inches, and 3 75/100 inches. Is this triangle a right triangle?
So we apply. So we have, all right, so we put the numbers in. They have 4 and 5/10 squared, 3 and 75/100 squared equals 6 squared. And it says, how do you know which are side lengths A, B, and C? Once you solve for them, they are not equal to each other, so this triangle is not a right triangle. Now, how you know which one works? Well, you can try them in any order. There's kind of a, in this particular situation, when they don't tell you if it's a leg or hypotenuse, you just try them in all the different places, and if when it works, then yes, it's a right triangle. But if no matter which number you put where doesn't equal on either side of the equation, then it is not a right triangle.
A triangle has side lengths 10 feet, the square root of 205 feet, and the square root of 105 feet. Is this a right triangle? Explain.
Okay, so in this case, you would use the equation. Let me write it out. You have a squared plus b squared equals c squared. And then you use the values that they have provided. So you would have 10 squared plus the square root of 205 squared is equal to the square root of 105 squared. Okay, and then you solve it. So 10 squared plus 205 squared. So I have 100 plus, this would be 205 is equal to 105. The square root of those numbers gives a decimal, but then when you square it, and it would have like, that doesn't look good. When you have these square root situations like this, you would write it, I didn't put parentheses, but you would have the parentheses around it so you know to find the square root first and then do the square. So when you find the square root and then square it, it comes right back to that number. So 100 plus 205 is 300. 5 is equal to 105. That is not equal to each other. So now I'm going to try a different order and see if that works. I'm going to switch the square root of 205 and the square root of 105 and see if that works. So I'm going to erase this. Okay, so now I have 10 squared plus the square root of 105 squared is equal to the square root of 205 squared. So we know this is 100 plus 105 equals 205. 100 plus 105 is 205 equals 205. So is this a right triangle? Yes, it is.
Ray drew the isosceles triangle LMN and the segment LP. How can Ray tell whether the segment drawn is the height of the triangle?
So remember the corresponding base and height of a triangle are perpendicular. If segment LP, so that's LP, that's the line segment, is the height of the triangle LMN, then triangle LPN is a right triangle. So we have LPN, that is a right triangle. Use the converse of the Pythagorean theorem to determine whether triangle LPN is a right triangle. So you're going to put in the numbers. So here's LP, which is one leg, and then PN, and 3 and 7 inches is for LN. So we have 1 and 3/10 plus 3 and 5/10 equals 3 and 7/10 for C. So once you square all of them, these are the answers you get. Then they are not equal on both sides. So segment LP is not the height of LMN.
A triangle is inside a trapezoid. Is the triangle a right triangle? Explain.
All right, so we have this triangle inside of this trapezoid. It's asking, is it a right triangle? So we would use the Pythagorean theorem. So we have a squared squared equals squared. So leg 1, 10 squared. Leg 2, 9 squared. And our hypotenuse is the square root of 181. And the square root of 181 and that has to be squared. Alright, so 10 squared is 100, 9 squared is 81, and then 181 squared is going to come right back out to 181. And so 100 plus 181 is 181. So these are equal, which means it is a right triangle.